So now let's talk about the Coulombs law. But before that, I would like you to just remind the thing which were in force of gravitation. So in force of gravitation, suppose there are two masses m1 and m2 kept at a separation small r from each other. Then the force of attraction F acts between these two objects. And according to Newton's law of gravitation, this force is proportional to the product of their masses, and this force is inversely proportional to square of the distance between the two. And now just come to this case of Coulomb's law for electric force. Suppose there are two charges Q1 and Q2 kept at a separation of small r. So just assume that here Q1 and Q2 both are positive just for now. Then what will be the direction of the force? You must be remembering that the like charges repel each other and unlike attracts, which is the law of nature, of course. So in Q1, a force of repulsion F is experienced in this direction, and the same amount of force will be acting on Q2 in opposite direction as per the Newton's third law. So according to Coulombs, this particular electric force is found to be proportional to product of their charge magnitudes and inversely proportional to square of the distance between them. So it is on the same line as it was the case with gravitation. In law of gravitation, the same results was there, that force is proportional to product of their masses and inversely proportional to square of the distance. So here also, so you can easily remember this as you already know the law of gravitation. So inverse to the square of the distance is known as inverse square law. So on combining these two findings of Newton and here in case of Coulomb, so for law of gravitation we can write it like F is proportional to m1 m2 divided by square of the distance, and in case of Coulomb's law we can write it like F is proportional to q1 q2 divided by r square. So we can remove this proportionality sign by introducing a proportionality constant. So in case of law of gravitation, the proportionality constant is capital G. You already know that. So it is capital G into m1 m2 divided by square of the distance, and here capital G is universal gravitational constant. And do you remember the value of this capital G? What is that? It is 6.67 into 10 raised to the power minus 11. And what is the unit? From this formula you can easily see that unit of capital G will be F into R square divided by mass into mass. That means Newton meter square per kilogram square. Most of the time you don't need to remember the units. You can just use the formula and formulate the unit. So capital G here is 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. It is known as the universal gravitational constant. Why its name is universal? Because it is applicable over the entire range of masses. Everywhere in the universe, wherever this force is acting, the value of capital G is going to remain the same. 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. Now come back to the Coulomb's law. Here the proportionality constant is K. We are using a small letter K because the capital letter is reserved for something else that you will be using in a short while. So here capital F is equal to K, Q1 Q2 divided by R square, and K is the electrostatic coefficient. Here K is named as electrostatic coefficient. In MKS system, unit of charge is Coulomb. So if we say that in case of MKS system, the unit of K will be Newton meter square per Coulomb square, in the same way as it was here, Newton meter square per Coulomb square in case of law of gravitation. So the value of K was found experimentally, and it is 9 into 10 raised to the power plus 9 into Newton meter square per Coulomb square. So 9 into 10 raised to the power 9 is plus Newton meter square per Coulomb square. And this K, which is electrostatic coefficient, can also be written as in this form: 1 divided by 4 pi epsilon naught. 4 is 4, as you know. The pi, the same, 3.14. And the term epsilon naught. So epsilon naught is basically electrical permittivity of free space, and its value in MKS system is 8.85 into 10 raised to the power minus 12. And what will be the unit of measurement? 4 into pi has no unit. So unit of epsilon naught has to be inverse of that, the unit of K. Unit of K is Newton meter square per Coulomb square. So for epsilon naught we can write Coulomb square per Newton meter square. And finally we can write the Coulomb's law in this form for MKS system. It is F equal to 1 upon 4 pi epsilon naught multiplied by Q1 Q2 divided by R square. This formula is to be used very frequently in electrostatics. So just remember this formula, and it's not difficult to remember it. It is same as the law of gravitation. In place of capital G, it is 1 upon 4 pi epsilon naught, or simply K. There are few more aspects that I would like to tell you about the Coulomb's law. What we have learned so far about the Coulomb's law. The force acting between two charges can be written as F equal to 1 upon 4 pi epsilon naught into Q1 Q2 divided by R square. Or we can write it simply F is equal to K into Q1 Q2 divided by R square, where K is 9 into 10 raised to the power 9 Newton meter square per Coulomb square. So it is electrostatic coefficient K, which is written as 1 upon 4 pi epsilon naught, and the value of epsilon naught is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. If you consider the CGS system, means all this was for MKS system. All these values are for MKS system. So if we talk about the CGS system, then the unit of charge in CGS, or the centimeter gram second system, is known as stat coulomb. So stat coulomb is the unit of charge in CGS system, and its value is selected in such a way that proportionality constant K becomes 1 in case of CGS system. That means we have assumed 1 Coulomb equal to 3 into 10 raised to the power 9 stat Coulomb. And if we use this Coulomb's law in CGS system, then automatically the value of this electrostatic coefficient becomes 1. So just remember this thing, it's very important. Suppose in case some question is given in CGS system, then you must know that K is 1. So formula becomes simply Q1 Q2 divided by R square. But remember that here Q1 and Q2 are to be used in stat coulomb, and you can convert coulomb into stat coulomb using this relation that 1 coulomb contains 3 into 10 to the power 9 stat coulomb, and the distance R is to be measured in centimeters. So whatever force you get in this way, the force will be in what? What is the unit of force in CGS system? Of course, dynes. Dynes is the unit of force in CGS system. Newton is the unit of force in MKS system. Force that you will get using this formula will give you the value of the force in dynes. Whenever we want to use Coulomb's law in CGS system, then the first thing you should remember that stat coulomb is the unit of charge in CGS system, and coulomb is of course in MKS system. So 1 coulomb has got 3 into 10 to the power 9 stat coulomb. the value of the proportionality constant in CGS system becomes 1 because this conversion factor for the stat coulomb is used that way. So that K becomes 1. So formula becomes F is equal to Q1 Q2 over R square, where Q1 and Q2 are to be measured in stat coulomb, distance R in centimeters, and force resulting will be in terms of times. And one more point. Suppose the two charges Q1 and Q2 are kept at some separation and the medium in between the charges is air or the vacuum. If it is the case, then the formula which we have written is correct. Means this formula is based on this fact that medium between the charges is either air or just the vacuum. But sometimes there may be some other medium also between the two charges. Of course, that medium cannot be a conducting medium, because if the medium were conducting, then individual identity of Q1 and Q2 will no longer exist, because using that conducting medium, the charge will be redistributed between these two objects. So, of course, we cannot talk about the conducting medium in between the charges. So, what sort of medium we can talk about is the insulating medium. And one piece of information for you at this point is that dielectric is another name for the insulators. Dielectric medium is basically stands for insulating medium. And there is a constant capital K defined as dielectric constant. You will be given with this value in case the medium is given to you. So it is known as dielectric constant. The only difference that we use in the formula is this, that F in MKS system, F becomes 1 upon 4 pi epsilon naught into K. K is dielectric constant into Q1 Q2 divided by R square. Suppose two charges are there, Q1 and Q2, at a separation R, and if there is medium air or the vacuum, then force acting is F naught, suppose. So F naught will be written as 1 upon 4 pi epsilon naught into Q1 Q2 divided by R square. And in case we introduce the insulating medium, then the force acting between the same two charges for the same separation will be 1 upon 4 pi epsilon naught into K into Q1 Q2 divided by R square. So if we divide F naught divided by F, then its value will be what? You can see the value is going to be K. And for dielectric medium, value of K is always greater than 1. So you can define the dielectric constant using this relation. Means dielectric constant K can be written as F naught over F. So dielectric constant is the ratio of the forces acting between two charged particles when they are kept in air or the vacuum, to that with the force when there is a medium. So that is how you can define the dielectric constant for now. Otherwise, in later chapters, we will be exploring the further details of this dielectric constant, and we'll talk more about the dielectric medium and its characteristics. So for now, you just remember this, you just learn this, and these things will be clear to you later on. Have faith.